All right, everybody, what we are going to look at in this lesson is how to uh, use or create an arithmetic sequence, meaning that we're actually going to be writing the sequence based off of a series of numbers that we have. Now remember, an arithmetic sequence, or first, let me backtrack a little bit. A sequence is really just a function of some kind. Well, an arithmetic sequence is a linear function, meaning that it just is, slope, y-intercept, stuff like that. Well, excuse me, I just had something in my throat there. Okay, it looks like we're doing okay now. An arithmetic sequence is just a linear function when everything boils down to it. Now, what sets a sequence, the reason why we can identify it as a linear function is this right here, the common difference. The common difference is really the same thing as, oh, my pen doesn't want to write now. It's like the universe is conspiring against me to make this lesson here. Here, this is what we would refer to as the slope of the linear function, which could be found as saying y2 minus y1 over x2 minus x1. Well, here they call it d, okay, for common difference. Now, let's go back in time a little bit to your Algebra 1 linear function stuff, and I guarantee you this is going to ring a bell. Y is equal to mx plus b. This is the slope-intercept form of a linear function. Now, it's called the slope-intercept form because the equation itself contains the slope, the variable m, and the y-intercept of the function, whatever b is. Well, depending on your algebra instruction, or maybe in geometry, even algebra 2, you might have seen this form of a linear function. Y minus y sub 1 is equal to m times x minus x sub 1. This is called the point slope form of a linear function because it contains the slope, obviously m, and a point formed up of the x sub 1 and the y sub 1. Now, this is something that personally I think is much more useful than the slope-intercept form if we had to actually write an equation of a line. However, when I teach the point-slope form, I don't like the way it's presented. This is the way any textbook or online resource is going to present it. When we're having to graph these things, especially if we're using a graphing calculator, we always want it in y equals form. So I like to present the point slope form in y equals form. And so this is the Pearcey version of the point slope form equation. And if you notice, it has a striking resemblance to the formula that's presented to us for how we're going to write the equation or the sequence of an arithmetic sequence. Here, this is the same thing as our slope. All right. This is really supposed to say a sub 1, meaning it's like our first y value. Okay. In, that's the same thing as x. The only thing that's different is the reason why we say this is a 1 here as opposed to x sub 1 is because this right here is the same thing as my first y value, and so the first y value comes from the first x value. That's why in parentheses it says x minus 1. So this is literally just the point slope form written in the way that I normally teach it in class, where they're using the first y value or the first term using the vocabulary for sequence, and there you go. That's all there is to it. So what we're going to be looking at is we're going to see, okay, well, how can we identify, is a sequence going to be arithmetic? And if it is, can we write a function for, or can we write the sequence for it? And can we, use that to figure out what some terms are going to be? Now here, what it's asking us to do, they're giving us a sequence of numbers, and we're asked to determine if the sequence is arithmetic. Now, if it is, identify what is the common difference. All right, so let's see what we have. Now, if we were in an algebra classroom, I might turn this into a table of values where we have, x and y, where this is my first x number, this is my second x number, and this is supposed to say 1.2, 3.5, this is supposed to say 5.8. So this is my third x number, my fourth x number, and my fifth x number, basically. Okay? If we were in an Algebra 1 classroom and we put this in a table, I would say, okay, well, can you write the equation of this function, especially if it's linear? Well, the way we would demonstrate it, remember, slope and the common difference are the same thing. Slope is y2 minus y1, the difference of the x's over, the difference of the y's over the difference of the x's. So the way that we look at this, we say, well, what is the difference of the y's and the x's? So here, I'm going to take the difference. I'm going to say 10.4 minus 8.1. Take the number on the right and subtract the number to its left. So if I say 10.4 minus 8.1, I get a difference of 2.3. And I'm going to go to the next one. So 8.1 minus 5.8 also has a difference of 2.3. 5.8 minus 3.5 has a difference of 2.3. And so does 3.5. If I subtract the 1.2 from it, that also has a difference of 2.3. And the difference of the x numbers, 5 minus 4, 1, 4 minus 3 is 1. The difference of the x numbers is all 1. So in this example, is it arithmetic? Yes. It is arithmetic, and the common difference is 2.3. And there we go for that one. So the next sequence that we have, same thing. We can look at this as, x equals y equals, where the sequence themselves, the term numbers that we see, those are like our outputs. This is when x is 1, x is 2, x is 3, x is 4, and so on. Now the x numbers, you can see again, all are going to have a difference of 1. So we really want to look at what are the differences of the term numbers that we have. So 32 minus 16 is a 16. 16 minus an 8 is 8. 8 minus a 4 is a 4. And 4 minus a 2 is a 2. Well, the difference between the term numbers, the y numbers, the outputs, however you want to think of them, the difference of the output numbers here are not the same. So we'd say no, this is not an arithmetic sequence. Now the pattern, what's happening is it looks like we're taking the number that we have. It almost looks like we're taking the number that we have and squaring it. Now it doesn't quite work for, or maybe we're just saying 2 to the, yeah, that's what it looks like. It looks like we're saying 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, and then 2 to the fourth power is 16, and so on. So the pattern that we're seeing here is we're saying 2 to the nth power, and that's the pattern that we're seeing in that one. So the next one that we're going to look at here, let me pick another color here, so that way not everything blends together. So here, what we would see, and we'll dispense with the x and the y at this point. I think you can kind of get the idea of how we would look at this as a table, especially from an algebra 1 perspective, trying to write a function. So here we would say, okay, well, take the difference 1 over 60 minus 1 over 30. Well, that gives me a negative 1 over 60. 1 over 30 minus 1 over 20 also gives me a negative 1 over 60. And make sure we check all of them. 1 over 20 minus 1 over 15 gives me a negative 1 over 60. And 1 over 15 minus 1 over 12 also gives me a negative 1 over 60, not 16. So yes, this one also is arithmetic. So yes, and the common difference is negative 1 over 60. So that is the first thing that we're going to be doing. We're going to take a sequence of numbers and see is it arithmetic or not. Basically, we're looking to see does it have a common difference, a slope per se, and if it does, we say yes, it's arithmetic, which means it's linear. So the next thing that we're going to do is, okay, well, can we kind of take the sum of some of these things maybe? Can we identify what things are going to be? Now, keep in mind, the generic kind of a sub n, the equation that they're giving us to write an arithmetic sequence, is whatever the first term is, plus n minus 1, meaning x minus 1, basically, plus times the common difference, which is the same thing as your slope. So here we want to know, can we write the first 4 terms of an arithmetic sequence when we're given the first one and the common difference? Okay, so it's no big deal. We can do this one of 2 ways. Looking at it, we can write the arithmetic sequence, meaning I can say, for instance, this one, I can write it as a sub n is equal to, well, a sub 1 is going to be 0.5, so I substitute that in for a sub 1 of the sequence equation that we have, plus, and what we want to know is, well, what is, say, the second term? So that is when n is 2, and I'll say minus 1, and the common difference is 0.25. Okay, well, let's simplify it and see what we get. Okay, so, and let's go ahead and change that n here from a sub n, because now we're going to be finding the second term, a sub 2. So a2 will be 0.5 plus 1 times 0.25. And so that really just gives you 0.5 plus 0.25, which is 0.75. And so that would be the second term. And we would pretty much do the same thing. For the third one, a sub n becomes a sub 3 equals, and here we have a sub 1 again, 0.5 plus 3 minus 1 times 0.25. And we'll evaluate this one again, see what we get. Well, here what we're going to get if we evaluate it 0.5 plus 2 times 0.25, well, that gives me 0.5 plus 0.5, which is just 0.1. Now, ideally at this point, you can start seeing the pattern here. The first term, a sub 1, is 0.25. The second term that we got was oh, sorry, I'm starting with the wrong number here. The first one that I wrote the common difference down. The first term that they gave us was 0.5. Term 2 that we got was 0.75, and a sub 3 that we got was 1. Well, you can see I'm basically just adding whatever the common difference is to the terms each time, so that means the fourth one has to be 1.25. So we don't have to actually write out the entire sequence each time, because the common difference is essentially just added to the term that came before it to get the next one in the sequence. So that can be very helpful. So for the next example, well, let's use that idea. So that way we don't have to write out the expression each time and see what we get. So here, a sub 1, the first term, is 60. Well, the common difference is 12, so I'm going to say minus 12 here, and that will give me a sub 2 to be a 48. And I can subtract that by 12, and that would give me the third term to be a 36, and I can subtract that by 12, the common difference, and the fourth term in the sequence would simply be a 24. And that's one of the things that we're allowed to use the common difference to tell. We can basically just add or subtract whatever we have. Now here, this one is where we do really have to use the rule. The a sub n is equal to a sub 1 plus n minus 1 times the common difference, because we're kind of being asked to identify the 6th, 10th, and 12th terms. Now, because they're not consecutive, like 1, 2, 3, 4, adding the common difference up until whatever we need to figure out isn't always very feasible. Like, just say, for instance, I wanted to know what is the 843rd term. We definitely wouldn't want to go through all of those numbers where we're just adding the common difference over and over and over and over again in order to figure out what that would be. That's why we want to use the rule. Okay, so here, well, let's figure out, well, what are they? Here, the first term is given to me to be 5 over 7. And so now I got to figure out what is the common difference. So, we subtract negative 11 over 14 minus negative 2 over 7, and you're going to get a negative 1/2. And subtract here, and we get a negative 1/2, and subtract here, and we get a negative 1/2. So the common difference is negative 1 over 2. So now that we know what the common difference is, we can write our rule to figure out, well, what would it be for the 6th, 10th, and 12th terms. So let's go ahead and figure out what those are. So a sub 6 would be found by doing this. We're going to substitute 5 over 7 for the first term, and we'll say 6 minus 1 for the stuff in the parentheses where we substitute 6 for n, and the common difference is negative 1/2. Well, let's see what we get. 5 over 7, this simplifies to be a 5 times a negative 1/2. So, and you really could just type this into the calculator at one time, but I don't want to skip anything because I have been noticing some of my students typing things into the calculator incorrectly. So if we show the step process here, hopefully if you don't get the same answer typing it into a calculator, well, you can try and go back and identify where the mistake was. So 5 times negative 1/2 is minus 5 over 2. And here the common denominator would be 14. So we would get a negative 25 over 14 when we simplified our answer. So here is a sub 6. So we got one happy answer. Now let's try our next one, a sub 10, because again, we could keep saying minus 1/2, minus 1/2, minus 1/2 over and over and over again. But again, just imagine if I asked you what is the 29th term. We wouldn't want to keep doing that over and over and over again. So that's where we need to be able to come up with a rule here. So a sub 10, in this case, is going to be the first term, 5 over 7 again, plus the next thing in there in the parentheses would be 10 minus 1 times the common difference of negative 1/2. And we get 5 over 7 plus 9 times negative 1/2, which gives us 5 over 7 minus 9 over 2, which again, the common denominator here would be 14. And using our calculators at this point, we definitely will get negative 53 over 14 as our 10th term in the sequence. So there's that happy number. And the last one that we'll do here is the 12th term. So a sub 12 gives me 5 over 7 plus 12 minus 1 times negative 1/2. And we'll condense this process just a little bit. 5 over 7 will give me, so that in parentheses I get an 11. 11 times negative 1/2 is a negative 11 over 2. Again, common denominator is 14. And I will, in this case, get a negative 67 over 14. So there is the 12th term of the sequence. And there we go. So the only other thing that we'll maybe be doing with something like this is maybe I could take the sum of the differences, or I'm sorry, the sum of them, but ultimately what we're looking at here is just, can you identify if something is arithmetic, meaning it is going to have a common difference, basically a slope, a constant change of y over x. And then from the common difference, can we create an equation and identify certain numbers in the sequence? So any questions at all that you've had during the presentation, please make sure that you write them down. Bring them to me when you see me in class or in tutoring. And thanks for watching, guys. We'll see you soon.